Hi guys, this is Tutor Chris, which is also known as Heritage. Okay, all right. So before we dive into today's lesson, today's tutorial, what do you even understand by Sodic equation? Whenever you heard about Sodic equation, these are equations that involve the square root. Are you get what I'm saying? Okay. Now, let's quickly solve this Olympiad Mathematics problem, which says the fifth root of 5 to the power of x plus 5 to the power of 12, all divided by 5 to the power of x plus 5 to the power of 2 equals to 5. All right. Okay, I would like to quickly remind us of some variable concepts. The first one is that whenever you're having the square root of a according to the law of indices, this is a to the power of 1 over 2, the same thing. All right. Guys, what I want to ask you now, what about if you're having the square root of a equals to 16? Let me say 4, okay? Equals to 4. What is the value of a? This is very simple. Since we said this is something like this, that means I can square both sides so that I will clear this root. So that will be the square will cancel the root. I'll be left with a equals to 4 to the power of 2, which is 16. See this variable concept here is very, very important and useful. And I will apply it in this concept now. Okay. So that means if I find a okay, let me clean that. Let me wipe that off. Okay. So automatically, that means I can also raise everything at the left-hand side to the power of 5 and this to the power of 5 so that the fifth root will be cleared off. Okay? So now let's say I'm having 5 into the fifth root of 5 to the power of x plus 5 to the power of 12, or divided by 5 to the power of x plus 5 to the power of 2. Okay? All to the power of 5 equals to 5 to the power of 5. That's cool. So that the fifth root of this will be cleared, and then I will be left with 5 to the power of x plus 5 to the power of 12, okay, being divided by 5 to the power of x plus 5 to the power of 2 equals to 5 to the power of 5, okay. I don't need to expand this, that is, I don't need to look for the actual value of 5 to the power of 5, because if you look at the left hand side, you're having the base, which are 5, and the base here is also 5, so that shows that I don't need to disturb myself to expand the exponent so that we'll have the actual value of this. I can leave it like that. And then I will cross multiply. Don't forget, 10 is same thing as 10 over 1, okay, by turning it into fraction. Because any number over 1 is still going to give you that number, okay? That tells us that 5 to the power of 5 is the same thing as 5 over 1. The reason I did this is that I want to clear the fraction here. So I want it to be in a simple equation form. Are you getting what I'm saying now? So that will be, this will multiply this and this will multiply this. So I'm having 5 to the power of x plus 5 to the power of 12 equals to 5 to the power of 5 into bracket of 5 to the power of x, okay, plus 5 to the power of 2. That's beautiful now. You can see this is getting simpler. So what I'm going to do now is that I want to expand this bracket so that the bracket will be left off, and then I'll be having 5 to the power of x plus 5 to the power of 12 equals to 5 to the power of 5, okay, multiply by 5 to the power of x plus 5 to the power of 5 multiply by 5 to the power of 2, 5 to the power of 2, sorry for that. And now, if you look at the question very well, you can see that some variable are having the power, which is x, while some of them are having number. And then before that, let's look at this, okay? You have a 5 to the power of 5 multiplied by 5 to the power of 2. This is multiplication. The operation is multiplication. They are having the same base, which is 5. And according to the law of indices, it allows us to sum all the powers. So that's 5 to the power of 5 plus 2. That's cool. I get what I'm saying now. And then 5 to the power of 5 plus 2 is the same thing as 5 to the power of 7. So these are entity here. This guy here is not 5 to the power of 7. Let me clean that up so that I can see how beautiful this is 5 to the power of 7. Okay, I will get that now. Now, I will collect the like times. That is, those variables that is having the power of x will come together, and those variables that is having the power of a number will also come together. So now, this will be 5 to the power of x, okay? And then this guy here, which is having to the power of x, will also come here. That is minus 5 to the power of 5, okay? Multiplied by 5 to the power of x, okay? equals to this guy here, which is now 5 to the power of 7 and then minus 5 to the power of 12. Oh my God, this is making sense, and I hope it's making sense to you. All right, now we're having this, but if you look at the left hand side, there's something common to both of them, which is 5 to the power of x, okay? And then if you divide 5 to the power of x by 5 to the power of x, I'm having 1 minus 5 to the power of 5 multiplied by 5 to the power of x, that's going to be 5 to the power of 5, okay, equals to something is also common to the right hand side, and that's 5 to the power of 7. 5 to the power of 7 divided by 5 to the power of 7, that's 1. And then according to the law of indices, let me also show you another concept now. Okay, now look at what I want to write on the board now. I'm giving 5 to the power of 12 divided by 5 to the power of 7. Don't forget, in my previous video, I've showed you that whenever the operation is division and the base is the same, that means I can subtract the power. So that means this is equals to 5 to the power of 12 minus 7, which is equal to 5 to the power of 5 to the power of what? Okay, that should be, oh, sorry. That should be 5 to the power of 5, okay? 5 to the power of 5. Now, this is minus 5 to the power of 5, okay? That's cool. All right, let's continue from there. Let's continue from there. Now, we're having that. And then from this down part now, you can see 1 minus 5 to the power of 5 is common to both of them. I can divide both sides by that, and this will clear off, okay? So I'll be left with 5 to the power of x equals to 5 to the power of 7. Now I can equate the power, that is x will be equals to 5. That is the base, equal bases will cancel out. I will have x equals to 5. So this problem that looks, oh my God, that looks impossible here, that looks large, that looks as if it's kind of difficult here, is being solved, and we get the value of x to be equals to 7. All right, so if you are new to my channel, or this is the first time or paraventure watching my video, or you enjoy any of my video, kindly subscribe to my channel and make sure you invite your friends to my channel. Don't forget, I remain Mathematics Clinic by Master Chris on YouTube, Mathematics Clinic by Tutor Chris on TikTok, and I'm Laplace Euler on Facebook. Thank you. See you next time.